So since a number of you will be gone for the soccer game, this is a video about polynomial division. We are going to use a new method today called synthetic division. So before we would have made a box for synthetic division, what we're going to do is we are going to just write down the coefficients. So we're going to write down that the coefficients are 2, -7, 0, and -4. Just want to make sure why that 0 is there. If I expand this out, it would be 2x cubed minus 7x squared plus 0x minus 4. Okay, I'm going to divide by 3 because 3 is the 0 of this polynomial. So not -3, I'm dividing by +3. So then I always bring down this first number. And then I multiply. 3 times 2 is 6, and then I add. -7 plus 6 is -1, and then I multiply. 3 times -1 is -3, then I add, and then I multiply. 3 times -3 is -9, and then I add. So my answer, when I write my answer, I know that my degree will be 2, so my answer is going to be 2x squared minus x minus 3. This is a 1x. If you can write that if you want. And then my remainder is -13, so I'm going to write that 13 over x minus 3. Now you might be asking, why didn't I just teach you synthetic division in the first place? It's faster. One of the reasons I didn't teach you synthetic division in the first place is it only works if we are dividing by a linear term. So synthetic division is a little bit limited because you have to be dividing by a linear term rather than by a quadratic. So that's one reason. And the other reason is that it's hard to understand why this works. I think it's a little easier to understand why the box works. All right, we're going to use synthetic division for this problem. This is just another example. We're going to write down our coefficients. And then when we divide, we're not dividing by the +3, we'll use a -3. Okay, then we bring down the 1, and we multiply. We add, and then we multiply. We add, and then we multiply. This time, our remainder is 0, so our answer works out to be a nice quadratic of r squared minus r minus 4. And that's just filling in our coefficients into a quadratic. There are also a couple of theorems this section. The first theorem is the Remainder Theorem. You can actually use synthetic division to find the value of a polynomial at a number. Polynomials have can have big exponents on them. They can work out to be pretty ugly numbers. But you can use the remainder to figure out the value of your polynomial at a certain point. I'll show you how to do that. So the theorem says if your function is divided by x minus a, then the remainder is p of a. So rather than, for this particular problem, we could plug -5 in, and we do -5 cubed plus 10 times -5 squared plus 29 times -5 plus 25. We could do that. But this problem says, well, there's another way. We can use the remainder theorem. So what we're going to do instead is we're going to divide this by x minus -5, or x plus 5. So we're going to do synthetic division now. So the coefficients would be 1, 10, 29, 25, and we're going to put a -5 here. Because this is x plus 5, we use the opposite sign. Okay, now we bring down the 1. We do negative 5 times 1, which is negative 5. We add. We do negative 5 times 5, which is negative 25. And we add. We multiply. We get negative 20. And we add. Our remainder is 5. So that means, without doing all of this math, I know that P of negative 5 is 5. I didn't need a calculator in order to do any of this synthetic division. I might want a calculator if I were going to do that problem without by hand. So it's just an alternate way of saying that this value is 5, but I would need a calculator to get there. Synthetic division allows me to get there without doing any calculator work. All right, so here is another type of problem that's asking that same question. A technology company uses the function r of x equals negative x cubed plus 12x squared plus 6x plus 80 to model expected annual revenue in thousands of dollars for a new product, where x is the number of years after the product is released. Use the remainder theorem to estimate the revenue in year 5. So we are going to do the remainder theorem, which means we're doing negative x cubed plus 12x squared plus 6x plus 80 divided by x minus 5. So if I do synthetic division, that would be negative 1, 12, 6, and 80. I'm going to divide by 5. And then I bring my numbers down. So I get negative 1, negative 5. 7 times 5 is 35. 35 plus 6 is 41. 41 times 5 is 205. So my remainder is 285. And so that's the amount. So r of 5 would be 285 by the remainder theorem. I'm claiming, and I would like you to check it, I'm claiming that if I plug 5 in, I get the same answer as if I do that long division or synthetic division. Oops, that x should be a 5. These are just alternate ways of getting the same answer. The other theorem for this section is the factor theorem. The factor theorem says that if you do all this long division, then you get a remainder of 0. So as long as you have a remainder of 0, then your function is a factor. And that also means that the value of the function is 0 at that point. So we are trying to show that x to the 4th minus 8x cubed plus 16x squared minus 23x minus 6 divided by x minus 6. We're trying to see whether it is a divisor or a factor. We're just basically trying to see if it has a remainder. So we're going to go ahead and do long division. Synthetic division, sorry. Bring down the 1. 1 times 6 is 6. Negative 2. Negative 2 times 6 is negative 12. Add, you get 4. 4 times 6 is 24. Add, you get 1. 1 times 6 is 6. The remainder is 0. So that means that x minus 6 is a factor. And then it says, if it is a factor, write the polynomial in factored form. So in factored form, it would be x minus 6 times this business, which would be x cubed minus 2x squared plus 4x plus 1. So since we got a remainder of 0, we also now know that p of 6 is equal to 0. And we can tell that when it's in factored form. If I plug 6 here, I get 0 times some stuff. I get a value of 0. All right, that is lesson 3-4B. Thank you so much. Bye.